amides. Remember that amides have a functional group of RCONH2. So this is amide. If it is secondary amide, we are going to consider more on the primary amide. Okay, we will not talk about secondary amide, their reactions. Let's focus on this. Okay, these are the ones you see in your exams. Okay, so now the number one reaction of amide. This amide, they have, remember, they have this nitrogen here which has lone pair. So this lone pair increases their reactivity towards reaction. So, but let's not talk about the mechanism for the reaction. Let's just go straight into the reaction process. So the number one reaction of amide I'll talk about is hydrolysis. Hydrolysis of amide. Okay, so when we talk about hydrolysis, it could be hydrolysis using water. If you use water to hydrolyze amide, it is going to proceed, but it's a slow reaction. The reaction is a little bit faster if you are using a dilute acid or a dilute solution of a base to hydrolyze it. Okay, so but the end point of the hydrolysis of amide is going to give you a carboxylic acid, right? So if I'm hydrolyzing with water for this case study, let's say we have amide functional group and we are hydrolyzing with water, which is a slow process, a slow rate determining step. So for this one, we're going to have RCOOH plus. What happens here is simple. Okay, so in this reaction, water will split into what? You have H and OH, right? So the OH is what comes here. The amine group leaves and picks the hydrogen. So you have plus ammonia here, right? So in this reaction, amide is treated with water to give you the carboxylic acid. That is for this case. So we can also use an acid. We can also use a base for this hydrolysis to give us the corresponding arachidonic acid salt or ion. Now the next one we'll talk about, number 2. We look at reduction. Reduction of amide. Now I say reduction. Reduction simply means addition of what? Hydrogen, right? So if you reduce an amide to get, what you're going to get is an amine. You get an amine, okay? You get an amine. So what do we use in carrying out this reduction? For this reduction, we can either use a solution of sodium in ethanol, or we can also use lithium tetrahydroaluminate, that is LiAlH4, that reducing agent I gave you in the previous video. So in this reduction process, I can say that RCONH2 undergoing reduction with lithium tetrahydroaluminate or sodium and ethanol. This would simply means addition of what? Hydrogen. So we're going to have RCH2NH2. What I simply did is simple. I removed the oxygen and I replace what? With hydrogen. That is simple reduction. So for example, if I use let's use ethanamide, for example. Let's use ethanamide. This is ethanamide, okay? If I use any of the reducing agent here to do this, I will have ethylamine. Ethylamine will be the product of this reaction, okay? So let's look at the next one, number 3. Dehydration. Dehydration of amide. Now, amides are dehydrated in a strong, they are in the presence of phosphorus pentaoxide, right? In the presence of phosphorus pentaoxide, when you heat up the solution, it will bring about dehydration, which is what? Removal of what? Water. And at the end of this dehydration, what is going to form? It will form a nitride. Okay? It will form a nitride. Okay, now, how can we get this nitride? Dehydration of amide to form a nitride. How can we get this nitride? Example, if I have RCONH2 and you are heating up in the presence of phosphorus pentaoxide, you are heating up this guy with the amide. So what will happen is like a dehydration, that is water, elimination of water will take place. Elimination of water molecule will take place. So if you look at this amide, you definitely see the water, H2O. So just remove this thing, remove it. When you remove it, The carbon to nitrogen here is a triple bond. So you're going to have RC triple bond N. So this kind of functional group is what we call nitrides. So this is going to give us nitride. Example, if I have CH3CONH2, okay, carrying out a dehydration process using phosphorus pentaoxide plus heat, okay, what will happen here is elimination of water. So when water leaves, I'll have CH3 C triple bond N. So this is what we call ethanonitride, or you can say acetonitride. So anyone you call it is fine. Okay. So the next reaction of amide is what we call the Hoffman degradation. Okay, the Hoffman degradation. So this Hoffman degradation, I didn't spell it well. The Hoffman degradation. Okay. So this Hoffman degradation is simply the breakdown of the amide group to form a primary amide. So in this reaction, the carbon in the amide is lost, okay, to form other things which in the reaction. So in this reaction, Hoffman degradation is simply the reaction of an amide group with a halogen Br2 plus a base potassium hydroxide to form a primary amide plus potassium thiazocarbonate 4 plus KBr plus water. So to balance this equation, I'll have to balance it by placing 2 here. Okay. Why am I putting 2 there? To balance the Br to be 2, right? Then put 2 here. Not 2, sorry. I already have 2 potassium plus 2 here, 4. So I have to put 4 here to balance the potassium 4. Oxygen is 1 plus 4, which is 5. I have 3 plus 1, so I have to put 2 here to balance the oxygen 5. Hydrogen is 2 times 2 is 4. I have 4 hydrogen here and 2 here, 6. So I have 4 plus 2. So I think it's balanced like this now. So this is the general equation for Hoffman degradation. Reacting this amide with halogen and what? Potassium hydroxide to give you an amine. So what you have here is called an amine. So this is simply the conversion of amide to amine. So you have degraded this guy. So degradation means that you are going to lose this carbon. You will lose this carbonyl group. You are going to lose this carbonyl group to other things, okay, to form potassium carbonate and the rest of the things that are there. So this is what we call the Hoffman degradation of an amine to form an amine. Take note of that.